Hello everyone, welcome back to my channel Xgene and proteinX. In this tutorial video, I'm going to talk about PVDF and nitrocellulose membrane. So if you do Western blot, you need to know in details about the PVDF and nitrocellulose membrane to select the right one. So to know about that, you need to watch this video till end. So let's begin. So first, you need to know about the PVDF membrane. So PVDF is a polyvinylidene difluoride is obtained by polymerization of the vinylidene difluoride. Whereas the nitrocellulose, it is also known as the cellulose nitrate and it consists of purified cellulose. So during membrane preparation, the cellulose nitrate is dissolved in a mixture of the organic solvent and then the solution poured on a smooth surface forming a thin film. And this is how nitrocellulose membrane formed. So next, you need to know the pore size of these two membranes. So basically, there are three different pore size: 0.45, 0.2, and 0.1 micrometer. And this size indicating the pore size of this membrane. So here, normally the 0.45 micrometer membrane is suitable for most protein plotting applications. But for the smaller peptides or lower molecular weight proteins like 15 kDa, you should use 0.1 or 0.2 micrometer pore size membrane. So for the 0.45 micrometer pore size membrane, it can bind more than 15 kDa protein. So for the more than 15 kDa protein, it has the strong binding with this 0.45 micrometer pore size membrane. But for the lower protein, like less than 15 kDa, it has the weak binding with this kind of pore size membrane. Because 0.45 micrometer, it is the higher pore size. So this is why the smaller protein, it cannot bind properly. So in that case, you need to select the 0.2 micrometer or 0.1 micrometer membrane. So for less than 15 kDa or smaller protein, it has the strong binding with this kind of 0.2 or 0.1 micrometer pore size membrane. So next, I need to know that binding capacity. So PVDF has the protein binding capacity around 170 to 200 microgram per centimeter square. Whereas the nitrocellulose membrane, it has the protein binding capacity of 80 to 100 microgram per centimeter square. So you can see, if you compare, so you can see here that PVDF, it has the higher binding capacity compared to the nitrocellulose membrane. So next is the expression of the proteins in PVDF and nitrocellulose membrane. So here I will show you the two different blot with the same protein. So here we run the two different membrane but the same protein sample. So here you can see in the PVDF membrane, the protein binding, it is the stronger, but in case of the nitrocellulose membrane, the same protein sample, it bind weakly. So this is why PVDF, it has the higher sensitivity, but for the nitrocellulose membrane, it has the lower sensitivity of the protein. And because of the higher sensitivity, PVDF, it has the higher background noise as shown in the image. But for the lower sensitivity, nitrocellulose membrane, it has the lower background noise. And also the PVDF membrane, it can detect lowly expressed protein because it has the higher sensitivity. Whereas the lowly expressed protein, it cannot or very weakly detect by this kind of nitrocellulose membrane because it has a lower sensitivity. So this is why PVDF membrane, it is the best one here because of the higher binding capacity. So next is the binding affinity of the proteins in PVDF and nitrocellulose. So here I summarize two different membrane where I can see the higher in the PVDF, the same protein sample, it ran in these two different membrane, but you can see the same protein sample for the PVDF, it has the higher binding affinity. So here is a graph, it's showing that for all of the protein sample, the PVDF, it has the significantly higher binding affinity compared to the nitrocellulose membrane. So here also it has the higher binding affinity, and also it has the higher, a stronger binding with the protein, that PVDF membrane. So this is why PVDF membrane is the best one for the higher binding affinity of the proteins. So next is the membrane stripping. So I hope that you know about the membrane stripping. So I'll not discuss in details about the membrane stripping, but the membrane stripping, it can be stripped. The membrane can be stripped for several reasons. The first, number one, is that to use the same blot for several different detections. Number two is that to make correction. So if you make any mistake, so if you incubate the wrong antibody, then you need to wipe off the band, and then you can reuse the same membrane. So as you see in this figure, the before stripping it was like this, but after stripping you see the all of the band wiped off. So this is how the membrane stripping works. But for the stripping and reprobing, it is possible in the PVDF membrane without losing signal. But in case of the nitrocellulose membrane, stripping and reprobing, these are very difficult without losing signal. So this is why you can see, if you summarize, then you can understand that PVDF membrane is the best one compared to the nitrocellulose membrane. But also it depends on the different kind of the application. So in different kind of the application, these two membrane use also different. But I recommend the PVDF membrane for the Western blot. This is the best one. So this is all about the overview of these two membranes. So I hope this video will be helpful. If you like this video, kindly hit the like button, share it, and please subscribe my channel. And if you have any queries, kindly write in the comment section. Thanks for watching.